Right, hello everybody. Today we're going to learn about natural logs. So I'm going to write natural logarithms. So before we do that, let's just kind of do a recap. So in the past, we learned that 2 to the power of 3 equals 8. This is an exponential form. We have a base raised to an exponent and it gives us an answer. And we know if anything is exponential that it has this form. We also learned that the inverse of exponential functions is called logarithms. So if we were to convert this in logarithmic form, we're going to just kind of write down the letters for a second just so we can remember. We know that it's in this format. That is going to be log your base. So if you went up here, this is your base. This is your exponent. And this is your answer. So that's kind of how I label it. So we see that log base 2 of 8 equals 3. So if we think about this, if 2 is our base and 8 is our answer, does it make sense that 2 to the power of 3 gives us 8? Yes. Logarithms help us solve for the exponent part. So we also learned about 10 to the power of 2 equals 100. If we converted this to logarithmic form, we said log base 10 of 100 equals 2. We talked about in the past the significance of 10 and how we've used it so often and that we called it the common logarithm. So since this is a common logarithm, this was used so many times that we created a shortcut for this. So instead of writing log base 10 every single time, mathematicians just decided, I'm just going to write log. And then you have the 100 equals 2. With this notation, we are assuming that a 10 is there as the base. So anytime we have logarithms and you don't see the base, we know that it's a 10, and we call this the common logarithm. So this is just kind of like a shortcut, something nice, less writing. So now we move on to e. So for a lot of us, seeing the variable seeing the irrational number e can be strange because there's not many times that we have a letter as a base that's not a variable. So remember, e is like pi. E equals 2.718828459045 ... It is a number. So technically, if I was going to write this in logarithmic form, I would write log base e of 7.39 equals 2. And technically, there's nothing wrong with this. But remember, e is the natural number of growth. So e just appears in a lot of mathematics that you will see in the future in your more advanced classes. So once again, mathematicians decided, I use this e so many times, let me think of a different notation for this. And to distinguish it from the common log, we are going to write something called ln. So ln is the same thing as log base e. So we would write this as ln of 7.39 equals 2. And what we call this is the natural logarithm. Which is funny because if you look at the letters, this is an N, this is an L. It's not called NL, it's called LN. So that can also be a little strange sometimes, but just remember, this is just people in the past making these decisions of what we call things. But don't let any of this confuse you. All of this is just notation. So I'm going to do a couple examples with you so we can get comfortable with this. So let's say that you're given that y equals e to the power of x, and I tell you to write this in logarithmic form. First of all, you notice that you have an e, so you know from the bat that you're going to use ln. That's, going from exponential to logarithmic, and you hear me say it, exponential to logarithmic. ln is still logarithmic, it's just called a natural log. So ln, I'm going to pretend to write my e as my base. I'm going to write my answer, which is y, and I'm going to equal it to my exponent, which is x, and then you would be done. Let's keep going. This time ln 1 over e squared equals -2. This is the one that really messes with people because people think that they see an e as a base, but it's not there. Remember, this part is the answer component of our logarithm. There is still an e here that is not shown. Remember, we never write down the base, but it is there. So if we were going to write this in exponential form, we know that our base is e because this ln tells us that the base is e. We know our exponent is -2, and we know our answer is 1 over e squared. Once again, I'm not evaluating anything, I am just converting. So this is what we call converting. So now we're going to move on to evaluating. And if you remember anything about evaluating, we did something like this in the past. We said log base 2 of 8 equals blank. So if we label this, we know this is our base. We know this is our answer piece. And we know that logarithms that we're looking for are exponent. So 2 to the power of what gives me 8? This is 3. Or sometimes we write it like this to help us see it. So once again, I'm going to do an example. ln of 1 equals what? So I'm going to do the same thing. What is my base? My base is e. So in my head, I'm going to be like, oh, e to the power of what gives me 1? Well, I know that e is a number, and if I raise any number to the power of 0, it's always going to give me 1. So that's why this answer is 0, and I would box that in. This is called evaluating, because when you evaluate, you actually get an answer. To do one more, ln of 1 over e cubed equals blank. Once again, what is my base? My base is e to the power of, I don't know, equals 1 over e cubed. So I know that in order to get something that looks like this reminds me of negative exponents. So I believe e to the -3 is that. So this would be -3. So this is called evaluating logarithms. And last but not least is something called solving. So solving is something like e to the power of x equals 4. So in other words, like 2 point something, 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 something to the power of what number gives me 4. This is going to be a really specific number that's a decimal. So how do I get x by itself? Well, I remember if I have an x as an exponent, I need to convert this to logarithmic form. I know my base is e, so I can't write log, then I need to write ln. So I'm going to write ln, pretend to write the e, 4 equals x. Believe it or not, y'all, this is the answer. The answer is ln of 4. But if I read this, it's ln base e of 4 equals x, technically. And if I put that in the calculator, I am going to get 1.39 if I round it. But the beauty of this is most mathematicians would just leave it as ln 4. It's just much cleaner. I mean, the answer to this is actually 1.3862943361. But just to leave it as ln 4 and then can refer to your calculator to chart later to find the exact value is wonderful. So, I'm going to do one more example. Maybe I'll kind of turn up a little bit on this one. Let me do 2 ln of x minus 4 equals 4. One thing I want you to notice from the bat is that 2 is in the front. So 2 is multiplying ln base e of x minus 4. I want you to take notice that this is a whole package deal right here. This is not separate, it is together. So it's 2 times all of that. So your first step is you should get rid of that 2 in the front by dividing by 2. So when you divide by 2, you get ln base e of x minus 4 equals 2. A lot of you probably here want to add a 4, but no, you can't do that because remember that x minus 4 is the answer component of it. So we have no choice but to convert this into exponential form. And you know when you see ln that your base is e. So this becomes e to the power of 2 equals x minus 4. You understand now that e to the power of 2 is a number. It's 2.7 something 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 to the power of 2. It's going to be a long decimal. We don't have time for that, so we're going to leave it as e to the power of 2, and then we're just going to add 4 on both sides. So we end up with e to the power of 2 plus 4 equals x. If we didn't need the decimal badly, we would just leave it as that. But just to prove to yourself, it's proof to me that you can actually find the answer and that you know it's a number, go ahead and put this in a calculator, and you should get 11.39. So that is pretty much it when it comes to natural logs. Remember, if you are having trouble with this, it's two things. A, just that it's new, that the notation is confusing, we have random variables, it seems like it's doing a lot. So that's one thing that you're going to have to overcome. The second thing is maybe your understanding of logarithms in the past unit is not as strong as you think. So I would really advise that you do review that as well. Because if you struggle with the past material, you struggled with evaluating something like log base 2 of x plus 4 equals 10. Like if you were having trouble solving something like this, it is understandable why you would have trouble solving something like that. Anyway, thank you for watching the video, and I hope all of you